Rocket Power by John Muchnikov. The setup for this experiment was relatively simple. The goal was to find how different masses affected forces on objects, and therefore affected the distance of the objects. I would use 3 balloon-powered cars, all identical, but with in identical pressures. They would have the same air pressure, the same size, the same route they would be, let go on, and the same force would be used by checking the pressure in the air balloons. Air pressure would determine the force, and the force would be affected by the mass based on each car. The independent variable for this experiment was the mass. The dependent variable was the distance, and it was important that all car models were identical in each way, so there was no changes in variation. My hypothesis was that if you increase the mass of the car, then the distance will decrease. More mass is equal to less velocity when applied to the same force. The force was identical for each car because the air pressure I kept identical for each balloon. Therefore, the only independent variable that could be found was the mass that was added to each car. With little resistance from the friction, I used frictionless floor, and similar pressure, the independent variables are relatively decreased to just the mass. The materials that I needed for this experiment were as follows. I had 3 kits for car models. I had a wooden track railing that kept the cars on a straight path, 3 balloons, identical shape and size, air, a steel-slotted weight set, a tape measure, a pencil, paper, stopwatch, safety clips to keep the balloons sealed without completely sealing them, goggles for safety, and tape to outline the route the cars would travel on. The procedure for this experiment. I built 3 identical cars. I set up the track. I created data tables so that I could input my data as I did the tests. I filled the balloons with the air to the specific pressure. I placed my safety stoppers on the spouts of the balloons to keep the pressure stable while doing experiments. I taped the balloon to the car without any weight. Then I taped them to the cars that had weights on them. I performed 3 trials in the control car, 3 trials in the car with the 50 grams of weight, and 3 on the car with 100 grams. I redid the experiment with the 2 other cars with the added masses, and I used identical conditions to make sure that there was no changes in variables. I took down the times and the distances from each trial, entered the values into the tables, and formed conclusions. As you can see from the data tables here, car 1's trial in seconds, car 2's trial in seconds, and car 3's trial in seconds can be seen above, and the cars 1, 2, and 3's trials for meters can be seen below. The trial in seconds seemed to increase relatively with the mass, as well as the distance obviously decreased, as we can see here. This chart shows the relative average distance and average time for each car. The blue represents the average distance for car 1, car 2, and car 3 over their 3 trials. The average time can be seen in red for car 1, car 2, and car 3. This is the average of the 3 trials done on each car. The conclusion. I felt that my data was reflected in the hypothesis. It seemed that the cars with more mass had less distance and increased time, which was an added, unexpected occurrence. It seemed that the increased weight did result in decrease in distance. One of the errors that I saw in this experiment mostly had to do with the uncontrollable variables such as the weather and the stability of gas, how gas performs differently depending on the situation and how the molecules expand and how the molecules react depending on, the amount of temperature. I think that by adding more number of cars per weight and doing this experiment with multiple groups, different weights, could also expand the experiment and help it to be even more correct. Thank you very much for watching, and have a good day.